Assalamualaikum and hi everyone. My name is Hashima Abdullah. Today, I'm excited to share with you PROAUTO Berhad proposal for our new electric vehicle or EV assembly plan. A project that positions us at a front of sustainable mobility and industry innovation. Resizing the electric vehicle opportunity. Let's begin with why PROAUTO is entering the EV sector. The global EV industry is experiencing rapid growth, and this is a strategy opportunity for us to diversify and future-proof for our business. By investing in this sector, we not just following a trend, we are setting ourselves for a long-term competitiveness and expansion in a market that only going to get bigger. Our vision is to establish a state-of-the-art assembly facility, which we plan to have full operational by the fourth quarter of 2026, and the plan will be centered to our future growth and will help us capture a significant share of the evolving automotive market. Clear goal for a sustainable future. Our primary objectives are clear: to develop a world-class EV assembly factory, to ensure the facility is fully operational by the end of 2026, and to guarantee optimal workflow and the product quality throughout the plan. These goals are not just ambition, and they are achievable with the right planning and execution. Project scope element. Our project scope covers 4 key areas. First, plan design. We are focused on an efficient assembly plan layout and workflow optimizing to minimize productive. Second is technical specification. We are specifying all equipment and requirements needed for an advanced EV assembly. Third is financial analysis. A true assessment will ensure the project is viable and profitable. The last one is risk management. We have to comprehensive mitigation plan to address potential challenge before they arise. A robust and replicable methodology. To deliver this project successfully, we are following a robust and replicable methodology. Planning. We start with a detailed project setup and requirement gathering, and then next is simulation. We use a process modeling and simulation to optimize every step before implementation. And the last one is risk assessment. We are proactively identify and mitigate risks to keep the project on track. Key tools and technique. We are leveraging industry-leading tools. For project management, we use PMBOK 7th edition and Microsoft Project. For design and simulation, we rely on AutoCAD Plan 3D and FlexSim, ensuring our plan layout and process are both efficient and scalable. Quality and compliance. Quality and sustainability are the heart of this project. We are implementing FMEA and Six Sigma DMAIC methodology to drive continuous improvement and minimizing defect. Our environmental standard align the IOS 14001 2015, ensuring we meet global benchmark for sustainability and compliance.
Hello everyone, my name is Muhammad Jazmi Wimuledi and I'll be presenting the design of EV assembly plan, focusing on 3 key parts: the plan layout, the essential capital assets, and the technical specification for the major equipment used. Let's get started with the layout of the plan. This is our proposed layout. It's designed for a smooth and logical production flow. We begin with the stamping area for shaping metal panels, followed by body welding using robotic welders. Then the chassis and body are assembled in a centralized section. On the right, battery packs are installed, and below that we assemble the drive unit. Once the vehicle is nearly complete, it moves to charging and software installation, then ends at the vehicle storage and dispatch area. This design helps reduce production delays and keeps the process streamlined. Our plan relies on essential machinery to ensure safe and efficient production. We use automated assembly lines to speed up repetitive tasks and robotic welding for accuracy and worker safety. Battery installation stations are designed for safe handling of EV battery modules, and drive unit assembly tools ensure proper alignment of motors and transmissions. EV testing rigs are crucial to test brakes, electronics, and drivability. Finally, utilities like HVAC system, compressed air, and fire safety equipment support the whole facility. Here are the technical specs for our main equipment. The ABB IRB 6700 welding robot delivers high accuracy and speed. Battery stations are semi-automated for safety and handle around 30 modules per hour. Drive unit assembly tools help align electric motors precisely. Every car is tested for software, braking, and drivability using our EV testing rigs and to support the whole operation. In summary, the plan layout is designed for efficiency and flow. The selected equipment ensures high quality production and automation and safety in mind. And the technical specs we've chosen are based on industry standards to support high performance. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hari Akmal bin Muhammad Sofyan. I will be presenting the phase implementation plan for our electric vehicle assembly facility, scheduled for completion by the end of 2026. This plan is divided into 4 key phases. Phase 1 is initiation and planning from January to June 2025. This focus here is on securing a strategic site with good transport, labour and utilities. Site surveys including environmental checks will confirm its suitability. At the same time, we will engage with regulators for licensing, build partnerships with technology suppliers, and form the project management team to guide the project forward. Next, Phase 2 is design and procurement, running from July to December 2025. This is where the full architectural and technical designs are completed, emphasizing a lean manufacturing layout. We will issue RFPs for key machinery like robotic welders and EV testing rigs, secure supplier contracts, and begin recruiting technical staff while forming training partnerships. Phase 3 is construction and installation, spanning January to September 2026. Groundworks and building construction will begin, including production halls, admin spaces, and utility installations. Machinery will be installed in stages alongside construction, with experts ensuring systems are mechanically, electrically, and digitally integrated for smooth operations. Finally, Phase 4 is commissioning and pilot operations from October to December 2026. This phase focuses on final testing, production dry runs, and comprehensive staff training. Regulatory approvals will be secured, and pilot production will help refine quality before we move into full operations. In terms of resources, staffing will grow from 25 in planning to about 200 during full operations, with an estimated total investment of Rm 100 million. With this structured approach, we are confident of launching a successful EV facility by 2026. Thank you.
Very good morning to all my friends. Today, my name is Muhammad Zuhaimi bin Zuki, and I want to present about financial analysis in PROAUTO final project. My financial analysis for my EV car factory PROAUTO, firstly is capital expenditure. All the significant upfront costs required to get an EV car factory up and running are included in the capital expenditure. Capital expenditure such as is land acquisition, initial training, factory construction and machine. This is a capital expenditure for my EV car factory PROAUTO. For land acquisition is RM9,250,000, including land 50 acres, site clearance and levelling, put fencing, road and drainage, legal fees. For initial training, we put training for our workers, safety training, process and technical training, land simulation, OJT, assessment and certification. Is for 150 person workers is RM1,455,000. For factory construction, we put power substation, compressed airline, cooling and HVAC, fire safety system, waste and water treatment, IT and MES network is RM2,050,000. This is capital expenditure for our machine. We got 7 departments, and every department have different machine. We got stamping department, we got body welding department, we got battery model line department, chassis and body assembly line department, drive unit assembly department, charging and software installation department, and vehicle storage and dispatch department. All round up, cost for buying machine is RM1,459.50. Cost for all machine. So we gather up all the cost for total expenditure is for initial training plus factory construction plus machinery and equipment plus land acquisition is 14,240,000 ringgit and 500. This is operational expenditure breakdown. The daily expense required to run the EV car factory are now known as operational expense or OPEX, such as monthly employee wages, monthly utilities, monthly maintenance, and monthly raw materials. I will explain more. This is monthly employee wages for our workers, which is 585,000 ringgit for monthly. Monthly maintenance for our machine is 123,500 ringgit. For monthly utilities is 180,000 ringgit. This is monthly raw material for our car factory, which is 2,698,000 ringgit. And we plus all the costs for annual expenditure is 30,360,000 ringgit for year 1, year 2 and year 3. This is our annually expenditure. This is ROI, Project Return on Investment. The project return on investment show how much profit the EV car factory is expected to make compared to the total money spent on building and running it, such as annual revenue, return on investment projection, and total net profit after years. This is our annually revenue for EV car factory. Sale for one car, 50,000 ringgit. After sale service, spare part, battery pack sale, year 1, year 2, year 3, year 4 and year 5. Below, return on investment projection. From that annual revenue, we make a schedule for return on investment projection from year 1 till year 5. Is a total net profit after 5 years. We put all the numbers according to the formula and we got ROI for our car factory is 92%. That's all from me, financial analysis.
Assalamualaikum. My name is Ali Farhan bin Asrul Anwar. Today I want to present about key risks identified. Firstly is supply chain degradation, global sourcing dependencies, lithium battery and semiconductors, and then equipment delivery delay, long lead time due to custom fabrication, robotic arm and delay impact installation and commissioning costs. And then the construction risk, weather disruption, labor shortage, last minute design change and contractor inefficiencies. And lastly is regulatory compliance and delay in permit and certification from authorized such as SIRIM, DOE and DOSH. And then the market and technologies risk. Firstly is market fluctuation, EV demand affected by fuel price, recession cycle and subsidy change. And then the technology obsolescence, fast evolving EV tech risk of yearly update, equipment lack of upgrade, past reduced competitiveness. And then the compliance risk impact, delay in securing approval for safety, environmental and worker protection standard, especially for battery handling, can install the entire project's timeline. And lastly, the dependency on global supply, critical components like semiconductor and battery are globally sourced. Advanced political tension or material shortage, such as rare earths, can disrupt operation and raise costs. And then the mitigation strategies. First, pre-qualify supplier, ensure multiple reliable sources to evaluate based on delivery performance, support and stability. And then the modular construction, prefabricated part improve build speed, reduce on-site disruption and enhance quality control. And then the contingent budgeting, allocate 10 to 15 buffer for cost escalation in material, logistic or redesign. And then the lastly is regulatory alignment, use Gantt chart to sync project fastest with permit schedule, early engagement with regulatory bodies. And then the FMEA application, the purpose of FMEA is firstly detect failure points early, and then the rank risk using the RPN, and lastly is guide mitigation step. What we can see the table is, firstly is component, failure mode, cost, action taken and the RPN. At the component, firstly is battery assembly system, the failure mode is loose welding joint, the cost is misaligned robot, and what we can action taken is optical inspection plus heat sensor, and the RPN is 168. And number 2 is high voltage terminal, failure mode is voltage error, the cause is PLC misconfiguration, action taken triple verification plus firmware check, the RPN is 144. And then the lastly is control sensor network, and the failure mode is signal instability, the cause is dust or uncalibrated sensor. The action taken is routine calibration plus HVAC system. The RPM is 132.
To conclude, our EV assembly plan proposal is built on a strong foundation of efficient layout, advanced equipment, and reliable technical specifications. With each stage carefully planned, from stamping to testing, the project ensures smooth production flow, high product quality, and long-term sustainability. This initiative not only supports PROAUTO Berhad's expansion into the EV sector but also aligns with global standards in green manufacturing and innovation. Thank you for watching our presentation. I truly appreciate your time and attention.